Good afternoon. Welcome to the webinar series by Pivot Cloud Solutions. In this episode, we're going to discuss ways and practical means of migrating legacy systems into cloud using platform as a service, in other words, without disruption to your operations. In particular, we're going to discuss practical ways of moving AS400 and AS400 applications into cloud microservices. I am your host today. My name is Guru Prasad. I'm the co-founder and the CEO of Pivot Cloud Solutions. Pivot Cloud Solutions is an innovative AI-powered, non-disruptive migration platform specifically targeted to migrate their business applications using innovative artificial intelligence, which is trained to understand the business processes and the business flows and the data and migrate them into cloud at your convenience. We will start with a background of AS400s itself. AS400s, IBMI, and System I. There are experts who can describe at length what are the differences and what are the versions and how they work and why they have advantages and disadvantages on each and every one of them. However, this particular session is about not about why you decided to move, but it is about how you can move with the various options available in the market, commercial as well as the proprietary, and the innovation and emerging technologies that's coming into the market at this point of time. Let's start with the business itself and how the businesses operate within it. You may have heterogeneous systems, but mostly AS400s could be part of the entire business ecosystem rather than it is the system that's only operating on the environment. In the business view, all the processes looks simple enough, and they were a user you inputting and extracting the information from the system, and there's a backend processes there using your older technologies like a COBOL, PL1, or RPGL, or even some of them even Java has been implemented in the middle, and they'll be performing the business logic in the middle, and then you have a data stored in a database or VMS or flat files in the backend. In reality, what is actually happening is for every business process, it has been either amended or changed or modified over a period of time to accommodate the changing customer requirements or business requirements, um, or even added the new processes which uses the common functionality from the older code. It turns out to be more fragmented view of system. Every time you touch something, and there could be a multitudes of sub processes executing and performing, um, especially if you have an environment like a JCLs or the third party APIs are being interacting with the system. You have a much more complex view of the uh, internal systems going on. So that's where your biggest challenge comes into, how that entire understanding what is actually going on, and then moving them into cloud without disrupting and without losing the functionality during the process. Let's start with what are the ways or currently available options available for you to perform the same task. Current options are manual migration, which says what it says on the tin. Basically, you have experts or consultants coming in, and they would be examining the system by part, reading the documentation or source code or both, proposing a on an alternative solution. Either mostly it is an upgraded system or the newer version of the same platform, and moving the code and the data to the new platform, and give an opportunity to flip the button, which will now you can get rid of the old system. However, this is a risky, high costly, as well as the time consuming process. Recently, the cloud providers like Azure and Microsoft coming up with the moving the workloads to clouds. What it means is it will have background processes running on the mainframes could be moved into cloud with the technologies like a micro COBOL or open COBOL. If they are simple enough and they were self-contained modules which can run in a containered environment in the cloud, so which means you will get a lot of scalability as well as the security to be adapted onto those processes. This may work well if you have a simple enough processes and the business logic is not complex, has not been shared across the various business domains. Third option is code parsers. Code parsers are libraries that will read the code, like a COBOL to Java, for example. Literally, they read line by line and transfer that into an appropriate statements in the target language. A COBOL statement will be turned into a Java statement, one or more lines of a Java statement. Biggest problem with this is the generated code is unreadable and unmaintainable. Therefore, it may work for a simpler applications, but for complex applications, or if you are intended to modify them in future, this option could be a non-runner. Let's go to alternatives. In the recent times, especially last few years, there have been emerging technologies that's especially AI and cloud-based coming in the view. So let's discuss about a little more in depth. Cloud is getting cheaper and easily expandable, which means you can just take a cloud account and you can have as much capacity as you like with a flip of a button. With the rise of that, the cheaper computing and memory available in the cloud, AI is becoming more and more accessible to the more wider audience. It's a not only getting sophisticated, you are not actually waiting for weeks or days for a results to be executed. Now, it just within minutes, you can perform operations and analyze a multitude of data and give you the results in a fraction of seconds, which means you have an innovation and can be adapted to solve business problems. That's where Pivot Cloud Platform comes into play. Pivot Cloud Platform is built based on AI as a core, specifically trained to look at the business applications and solve the business problems. Let's examine how really does it under the hood. It does it in three steps. First one, process mapping. It looks at how the users are using your system from a user's perspective. By examining their own, their behavior and the way they are operating the legacy system, they can understand what is going on with the finer details of each and every flow will be accurately mapped and process will be captured. At the same time, it also looks at the data flows within the system. Your data is flowing from one end to another end and is being modified in the middle by the code. Either third party or your own internal code is changing the data as it passes through and then be stored in the backend. By looking at the end to end of the data, you can understand what is actually going on with the data itself. Once these two pieces of critical tasks being done, the models can now in a position to extract logic behind it. It look by looking at each business process, dividing them into microprocesses, and each process and using the data how it's flowing through. Now the AI is in a position to suggest this is exactly what is going on within the system. So by testing its various aspects of data integrity from end to end, you'll be able to suggest logic behind it without looking at the source code. So the biggest advantage here being, you if you don't have an access to the source code like a Delta software or a Adabas type of environments, the expertise are rare as well as the source code may or may not be available. You there is no need to for the AI to look into the source code itself. So with this all three steps executing in parallel, you will have an accurate process migration being happening without a manual interaction. All you need is a small operator who would be looking at the um, what and how you want it to migrate on your own pace. A typical implementation and timeframes would look like this. The first week to third week, the entire system would be documented, captured, documented, and process flows would be accurately mapped. Once that is done, you are in a position to either run them as an RPA, robotic process automation, even might modify them to for your own needs. It's a purely optional step. You don't have to go to that level at all. But from the week 4 to 12, you can just generate the microservices when the target language of your choice. For example, if you're a Java house, all the microservices generated would be Java, so Spring Boot microservices with an optional of a Angular or a Bootstrap front end. Or if you're a the Microsoft house, the microservices generated would be in a .NET format with ASP front end. And if you're a Python program, Python house or modern house like a Python or a Go lang, the microservices generated will be in those formats so that you will straight away, you can deploy those ones without any problem to Azure or Kubernetes or Docker of your choice. Once those three steps are done, you are in a position to test them accurately. You can run all your functional testing, regression testing, the user acceptance testing against the generated microservices to make sure they're actually performing as the old system in the old environment is performing. We also have an innovative comparison about testing where it can keep the old system alive on the new microservices in the cloud, and can test both of them with the same set of data and measure how the results are performing on the back end. Once that is the verification is being done, you are in a position to customize the code. You can add functionality, remove functionality, and change the functionality as an if it because it's now is in a modern format. Your developers will be easily accessible for your developers to change the code and redeploy the microservices without redeploying entire system. Analytics and reporting are available out of the box with a very little effort. You will be in a position to generate the analytics desktops or the dashboards, reports out of the box straight away. So this is the way you could migrate in a very little effort. Let's look at the real life, the results as we performed in the past. We achieved time savings of 70%. Instead of a project that's running for a year, is a less than 3 months, the project's been completed with a migration into the cloud. The cost be because of the cost, only one person instead of 10 people will be working on the migration project. Your cost is reduced from 80% of the cost to be reduced. DevOps, not only your security is being completely eliminated because a less number of people are working and a less DevOps support and all other tasks to be performed, you're also um, let the AI do the work accurately and as per your particular needs. Your DevOps are much more faster to move forward rather than waiting for the little smaller things to be set up as for the customer, the vendor requirements. As we come to the end of this session, we're in position to take some of the questions coming from the audience and can try to answer it here as much as possible within the reason. But we also available on our website to be contacted. You can request for a demo or more information. We'll be very happy to answer as much as we can. The first question is, did you support APIs that's been interacting with the system from internal and outbound, inbound and outbound APIs? The most of the systems would have may have inbound APIs or outbound APIs for the system for AS400. For example, AS400, you may be providing third-party reporting or the pricing, updated pricing is coming into the system via an API. Because these are all microservices being generated. Now, interfaces are not changed, or the input and output variables are not being changed. You have in a modern format is available, REST format available in the cloud. All you have to do is point the API targets to the cloud microservices and testing. Mostly testing is involved. Um, if there is a very customized output, maybe you have a different path of APIs going through the MQ. In that case, there may be an additional microservices, the additional small work to be required to do that, but it is not impossible. And because the formats and the microservices are one-to-one here, it's available exactly as it is. Your instead of AS400 and COBOL program, you have microservices running in the cloud. So it is definitely possible to achieve it. The next question we have here is can we continue developing while the transformation is going on? Of course it is. Our platform supports continuous integration and continuous development. So all we have to do is, in while the conversion is going on, the process that you are changing need to be rerun at the end of the transformation period. For example, you are working on a registration, customer registration portal or a sales portal. Those microservices need to be, well, it'll be generated right now, but you update it and you change the code and the AS400. So that continuous integration would trigger your regeneration of those microservices. So as soon as you update the AS400, there's a new microservice that will be generated in the cloud. So they will rewrite the older ones. By doing so, your continuous integration and continuous development cycle would be tightly integrated with the platform. So even you can trigger from your own continuous integration platform, trigger microservices generation automatically as you deploy the new code into the AS400s. Hopefully, we gave you a lot of ideas and introducing our innovative platform. Hopefully you will be able to see the possibilities without sticking to the older code because our options were limited until now. Thank you very much. and we'll hope you to see in the future episodes of our webinars. Bye.